Okay, sure. So moving on to how we use this. Now, where is this useful? This is basically useful if we're looking for two sides and contain angle. If you remember your laws of congruency, if you know two sides and the angle inside, you can prove triangles are congruent. Cosine law is really useful in a case like this. So let's go to the class example we did by drawing out the extension on the length and width. Let's instead try to use cosine law. Okay, so we said cosine law was equal to a squared, or a squared is equal to b squared plus c squared minus this big thing. And we can do this with sort of any version of it. We have a squared equals the other two added together minus this stuff. Similarly, if instead we're looking for b squared, we can say instead it's c squared plus a squared minus 2 times c plus a times cos of that. Or c squared, that's a squared plus b squared times 2 times a times b times cos of this one. Right? So it's like, which one do you have, which one do you don't? Don't worry. It looks a little bit weird initially. This is the formula you will have, and once you start using it, it's pretty simple actually. So, triangle ABC, where we have this, we have side AB and we have side AC. So let's go back to our naming. What can we call the bottom length? What side is that one?
A.
Yes, C. AB is side C. A little confusing. Okay, what about side AC? What's that called?
A.
It's opposite from B. And yes, this is angle A.
Oh.
So we have angle A, side B, side C. And we're being asked to find side A. So I want to know side A squared. Well, A squared equals B squared plus C squared minus 2 times B times C times cos of A. And what's nice is I have all of these things. I have B, I have C, and I have cos A. I should be able to find this. Okay, so let's substitute stuff in. So B was 6, so that's fine. B as 6, they look very similar. And C as 3. Minus 2 times 6 times 3 times cos 36 will give me a squared. 36 plus 9. Minus 2 times 6 times 3 times cos 36. A squared plus 15.87. Hey, this looks really familiar to me. So what's A?
We need to do square root also.
Yeah, exactly. Yeah, I want to pause it for a second. So let's take a look here. I see this being really similar to Pythagorean theorem. Let's try to actually apply this to Pythagorean theorem. What if instead I have a triangle where I have this angle is 90, and I know, let's say I know this side is 6, I know this side is 4, something like that, and I'm looking for this side. Well, what would I end up putting in?
6 squared plus 4 squared square root.
6 squared plus 4 squared minus, I'm saying, if this is post law, right? So my question mark, whatever it is, equals 6 squared plus 4 squared minus 2 times 6 times 4 times cos of 90. Anyone remember cos 90?
Oh, 0.1.
0.
Zero.
So notice what happens here. This whole thing goes to 0. 6 squared plus 4 squared is that squared? Oh yeah. So the Pythagorean theorem comes from this because cos of 90 is 0. So a little bit of a silly example, but it's because all of this ends up canceling out. So you end up with Pythagorean theorem is that without the whole last. Cool? Okay, with this. Now let's label our triangle right off the bat. This is often the issue, is just labeling things clearly. So I'm looking for the third side of PQR. I have QP 1.7, that's side R. QR 3.1, that's side P. And angle PQR is 1/10, or that's angle Q. So I'm looking for side Q. So we had this with A, B, and C. Now we have P, Q, and R. So help me write out this formula. I'm looking for Q squared.
So Q squared is equal to
So first of all, we have our sides. What are our two sides of
R.
Good. R squared plus.
P squared.
Good. Now minus 2 times.
5
Good. R, P, and then cos of what?
100.
Yeah, which is Q. Good. So just setting up the formula, it's the sides we don't have minus 2 times the sides we don't have times, or the sides we have, sorry, times the cos of whatever angle we're doing. So you notice this is really useful when I have two sides with angle enclosed. That's where this is. So let's solve. Q squared equals 1.7 squared plus 3.1 squared minus 2 times 1.7, 3.1 times cos of 110. An interesting thing to notice here. What's cosine of something in quadrant 2? 110 in quadrant 2.
Negative.
It's a negative.
Yeah.
So this last term minus a negative, we're going to be adding this last term here. Which makes sense. It's becoming the biggest size that we're solving for in this case. 1.7 squared plus 3.1 squared. You guys have time to type it in? I see thumbs from here. You're good, good. So Q squared is 16.1. So what's that tell you about Q?
Yeah. 4 point something.
Yeah, 4 point something. In this case, it's 4.01. Ask for the nearest tenth. 0. Great job. Now, of course, as you expect, okay, we have a trig thing. So now give me a nasty word problem. Now this is kind of interesting that the names were clearly chosen very kindly. We have city B, city A, and city C. So we have city Air, and then city B, which is 30 kilometers north. And then, okay, Churchville is 18 kilometers northwest. Now that actually tells me two things, doesn't it? If it's straight northwest, do I know any angles?
Wait, is it what is it?
Like if this is our compass, north, east, never eat soggy wieners. So then we have
90.
northwest.
45. 40.
Right, northeast. You in this course you won't get anything beyond that. In fact, even on a test, I don't think I would give you something that's requiring you to know that. But yes, if it's actually northwest, it's directly between north and west. These are 90-degree angles, so that means you have a 45-degree angle. So it's saying this here going 45 degrees is 18 kilometers. It wants to know BC, or if we're labeling these using our notation, it wants to know side A when we have side B and side C already. So to find A squared, that equals B squared plus C squared minus 2BC cos A. Please do type this in. There's part of why I want to have you doing this is there's a lot of keystrokes where you can make a mistake or miss a bracket here. So I just want to be checking that we're at the same spot. If not, let me know so that we can check in on what's happening. By the way, here you're using cos of 45, and I'm guessing you're just putting in your calculator using the decimal. That's great. But anyone remember cos of 45? Good. Good. Over two. You need to know this. Promise. You need to know your special triangles reading a circle. Probably what's happening, Jordan, is it's likely that the way you set this up subtracted this and then multiplied by all this stuff. So if you're needing, bracket. That's likely, if you're having trouble with the calculator, most likely it's that this isn't all being enclosed. Right, because if you go like -2 or minus whatever, and then times all this stuff later, or it's also possible, is your calculator in degree mode? The other possibility. Because cos of 45 radians is really different than cos of 45 degrees. Okay, so what's it?
21.45.
Awesome. A equals 21. It asks the nearest kilometers, 21.45. Now, this is actually one that sometimes people have an issue with. Because 21.45, some people will say, oh, 21.4, that rounds to 21.5, and then I round again. No. 21.4, we round that. Or if you're thinking, if you're really like, okay, I want to think about the hundredths, 21.455, whatever. If you're asking like about these two, it's basically, is it closer to 100 or closer to 0? It's closer to 0, so it rounds that. You don't like bump, then bump. The infinite bumping, that is it. So 21.0 is the nearest kilometer. How do we feel? Would you guys rather have a larger chunk of work time or keep going? Basically, I'll just tell you where we're going to go after this is what if you have 3 sides and you're looking for an angle? So that's the other form of the Cosine Law, is helps you find for an angle. Do you guys want a bit of time to work first? Pardon me?
I'm good with anything.
Good with anything? Any strong opinions? I see some keep going. All right, we'll keep going. Just get this over with. So, if we rearrange, find an angle, basically, we can go minus. Thank you, very nice. Wow, these nice ladies brought me flowers. How wonderful. Not right now. So we've got to find cos of A, or to find the value of A. Just rearrange this to isolate for cos A. You could even say from this point then A would be equal to inverse cos of this whole thing, b squared plus c squared minus a squared over 2bc. To find angle A, we can rearrange and isolate for that. Now this form of cosine law can be used to determine any angle in a triangle, and you just rearrange accordingly when you have a side. And remember, one of the other ways you can prove congruency is side, right? Well, wait, let's just remember that. What were the ways you can prove congruency of a triangle? Side angle side. Side.
Okay. Angle side.
Angle side angle. Good. Angle side angle. Does angle work?
No.
No, that proves similarity, but not congruence. And what about side angle?
No.
Oh yeah, we just looked at that with the ambiguous case of sine law. It proves that it's one of two triangles, but doesn't prove that they're congruent. Okay, good. So let's try this for angle ABC in the general case. Cos of B equals, looking at this, rearranging, what would that what would that be? How would, if this is the cos of A situation, let's think what would happen to the cos of B. Seem true, A squared plus B squared minus, or A squared plus C squared minus B squared. If the other one was cos of A is B squared plus C squared plus A squared, follows the cos of B would be A squared plus C squared minus B squared. And then over to A C. Cool. Was that? Yeah. Seem reasonable? Okay. Mr. Boyce, I trust you no matter what. Thank you. That's not what you're thinking? Well, fair enough. Cos C is B squared plus C squared minus, wait, I don't trust me either now. B squared plus A squared minus C squared over to A B. I'm guessing you don't actually want me to write it.
Whatever thing you're like,
Yeah.
whatever.
Is the thing that stays subtracted, yeah. And that's just based on how we arrange it, right? Because what ends up happening is, basically, when you're isolating for this, you're going to subtract this stuff away, then divide by this part. So the stuff that was positive becomes negative, and this stuff goes to the bottom. Okay, so looking for angles, I have these three sides, or I have A, B, and C. Does anyone know which angle, whether it'll be opposite, the biggest angle, which side it'll be opposite? Triangle. Like the largest angle will be opposite the biggest side or the small side? Biggest side. Yeah. If you think about in a right triangle, the reason the hypotenuse is always longest is because by definition 90 must be the biggest side. If, the other two add up to 90. So yeah, the largest side will always be opposite the largest angle. So I know that the largest angle will be angle A. Right? So cos of A is equal to. Now let's try to think about how this goes. So first of all, it's the other two sides squared. So B squared plus C squared minus A squared over, what's going to be the bottom? 2BC. Brilliant. Okay, now I'm just going to warn you ahead of time. There's a similar trap here as to what happened yesterday with Cosine Law when you're finding an equal. Let's just see if we fall into it. So I'm going to start here. And one other thing to keep in mind, you have your kind of invisible brackets here. Make sure you're dividing all of this by all of this. Not like all this by 2 and then multiplying by 8.9 and by, right, make sure that it helps. Yep.
So won't we take course on that side where it can be inverse of course?
Yeah, exactly. So then we're gonna inverse cos it at the end for sure.
Oh,
That's the trap lots of people will fall into is they'll say, oh, the answer is 0. Whatever. No, remember, then we're gonna inverse cos this all. 8.9 squared plus 12.6 squared. If you're wondering how you can keep this straight, I find most people are successful to just literally do this, hit enter, and then hit divided by, bracket this stuff. So 21.88 divided by 2 times 8.9 times 12.6, and I bracketed that whole bottom expression to keep it together. So I end up with 0.09755 ... In a case like this, sine, cosine, tan, they use fairly precise numbers, so it's worth carrying a whole bunch of decimals through when you inverse cos, or just using answer, because you're talking about like the difference between angle of like 86 degrees and 84 degrees when you're cosing them. It ends up being pretty similar in terms of the numbers. Like if you look at your trig table, cos of 84 is 9.9945. Cos of 86, 0.9976. Cos of 88, 0.9994. Cos of 89, 0.9998. And they're really close numbers, so just be careful that we're actually carrying through a bunch of decimals. So if that's what cos of A is, then A equals inverse cos cool. Did anyone put this in and find this answer?
No.
Well, good. As long as we kept our top and bottom together, you should be fine. I think actually once you start doing this, you're gonna find it pretty simple. But it's just the most common mistakes are forgetting to do the inverse cos or not keeping this and this together. Those are where you're probably gonna be mistaken. Okay.
You can press alpha X to make it look like a fraction on the calculator.
You can press what?
Alpha X.
Alpha X. Great. Oh yeah, it sets up that. It's a really good tip. Yep. What Tristan's just saying is like in the green lettering above the X, you see that like fraction set up. So you push alpha and then X. You can basically set it up so it's like a fraction. Then you just fill in what's on the top and fill in what's on the bottom, and it'll do that for you. So fine. Yeah, yours I think has the same. As long as you have a text instrument one, it'll use that. Alpha X.
Does it go to
No. You have to actually do math, sorry.
That's fine.
Wait, you have to do math and math. That sounds bad. I don't know what that. Okay, last one. Okay, what am I looking for? Which side am I looking for here? Which angle? You have to read blah blah blah. You're looking for B. So, oh, I almost put cos of P equals Q squared plus R squared minus P squared over 2QR. So 7 squared plus 8 squared minus 13 squared over 2 times 7 times 8. 49 plus 4 minus 169. Uh-oh, I have a negative number. I'm done for.
No.
Now just think, if I find a negative number here, what's that probably telling me? If I'm doing cos, I'm finding cos of a negative number, or inverse cos of a negative number, yeah? It's going to be second quadrant. Sorry, exactly. It's going to be something that's not true angle, right, between 90 and 180. Good, very well done. Okay, so divide that by... So I have cos of P equals negative 0.5, and at this point my evil teacher takes away my calculator and says you're never allowed to use the calculator again. But you say, hey, I know my reference angles, I know my my special triangles, I don't need a calculator, I got this anyways. How would you find P in this theoretical situation?
1.2 is 45.
What is 1.2?
Cos is 60. So in second quadrant, cos 120. So just remembering, the way I sort of think of these is I kind of just keep track of like going from smallest to biggest. So with sine, it's like 0, then 30 is 0.5, then 45 is root 2 over 2, then 60 is root 3 over 2, and then cos of 90 is 1. And the 60 is like the opposite, right? So, or sorry, cos is like the opposite. So it's like you go 1, root 3 over 2, root 2 over 2, 1/2, 0, right? You kind of work your way down. And then with your with your tan, it's just doing the sine over the sine inverse. Yeah. Good. 120 degrees. You can get to work. That's definitely enough of me talking. I told you I will come back and finish that proof with you. So those who are interested, will do that. The rest of us, let's get cooking and get doing some work. I would rather, if we're kind of picking a few from the 1 to 4 and a few from the 5 to 12, the 1 to 4 is more like finding a side. 5 to 8 is finding an angle, and then the last problem solving. Good? Get to it.
In the quiz, this won't come, but in that test as well, right?
Yes. Quiz and test include everything.